problem 11 has got a diagram here. It says the diagram shows a rectangle with a shaded region. Determine the area of the shaded region in square centimeters. Now, how do you find the area of the shaded region? Well, one of the ways of doing this is observe that this white area is a triangle, it's a right angle triangle. This white area is a right angle triangle. And when you add this and the shaded end area and this, you get the area of the rectangle. So you got to equal the area of a rectangle means you got an equation. So let's have a look at that. This is 5, this is 5, so the whole length is 10. So the area of this triangle, right, is half base times height. It's a right angle triangle. So if you take the base as 10, it's half 10, which is 5 times 3, which gives you 15. So that is half base times height. It's the area of that. Now, if you look at this other triangle, what's the area of that? Well, this side here is the same as this side, which is 6. And this side is given, it's 5. So you got two sides of this right angle triangle. So the area will be, again, half base times height. If I take the base to be 6, then half of 6 is 3, and 3 times 5 is 15. Okay, so now we've got these two white areas. The shaded area which we're trying to calculate, when you add it to those two other areas, you're going to get the area of the rectangle. Right? Because all these three give you the entire rectangle. And what is the area of the rectangle? The area of the rectangle is length times breadth. The length is 10, and the breadth is 6. 10 times 6 is 60. So now the shaded area is 60, and you got 30 on the other side. Shaded area plus 30 is 60. So you can do that mentally. And say it's 30. What must be added to 30 to get added to 30 to get 60? That is 30. And the units is an area, so the units are centimeter squared. Some people are very fussy about the units, so make sure you put down the units. So that's the answer to that problem. Now there is another way of doing this thing. You get to 30 in another way. And that is, I can split this rectangle into two equal parts by joining the diagonal. So if I join the diagonal, sorry. Join the diagonal, then what happens is now you've got 4 triangles, that, and you need to just calculate the area of this triangle. Well, the area of any triangle is half base times height. So the area of this one of the gray triangles, if you look at this triangle here, what's the area? The area is half base. Now I'm going to take the base to be this. Because I know the height. The height is the distance from the remaining vertex to the side. And the distance, the vertical distance. So this is the height. The distance from the vertex to the base. And that length, as we can see, is 10. So that's this shaded area. And then you can see this other shaded area is the same story. So you're going to add the same thing. So you're going to multiply this by 2 to get the entire shaded area. So 2 cancel with 2, 3 times 10 is 30. And if you recall, this is what we got the last time. So this is also 30 square centimeters. So there were 2 ways of doing this. Well, maybe the other ways, but I can see, at the moment I can see 2 ways. All right, so let me get on to the next problem. Which is number 11. Number 11 has a triangle here. In fact, there are 3 triangles, this one, and the large one. The large one is a triangle as well. And you are asked to calculate the value of x. And that's easy because you can add up all the angles of the triangle and you know it's 180. So the 50 there plus 30. Now this angle here is made up of x together with 3x plus x plus 3x. Right, and that gives you all the angles of the large triangle added. So when you add the angles of any triangle, you get 180 degrees. So you bring all the x's to one side, x plus 3x is 4x, and 180 minus 50 minus 30, because you take the 50 and the 30 to the other side, the 180 minus 80, which is 100. So 4x is equal to 100, so x has to be 25 degrees. So the value of x is 25. Then I have to put a degree there. X is 25. So that's, you simply use the sum of the angles of a triangle is 180 degrees to come to that conclusion. Okay, so let's get to the next problem. Here, the diagram shows the first 3 shapes in a pattern. How many sticks would there be in the 50th shape? Oh, so this is quite a teaser. Right, so we have to see what is the pattern. How is each shape created from the previous one? That's the important thing. How is each shape created from the previous one? Well, this triangle here, what I did was, I simply, to get this new shape, what we did was, oops. It's not allowing me to color this. All right, anyway. To this triangle, I have to add that one and this entire triangle. This and this entire triangle. When I stick it onto this, then I get the second shape. So this particular shape which I'm adding on, that shape plus the entire triangle. If I take that shape and I add it to this present one, then you're going to land up with take the same shape, then you're going to add up, add that and plus this triangle, and you can see I've come to this one here, this shape. So this is the shape that I'm adding. In other words, I can calculate how many matchsticks I'm adding at each, or how many sticks you're adding at each stage. We started off with 3. Then we added this shape here. This shape has got 4 sticks in it. 1, 2, 3, 4. So you added 4 to this. And then we added another 4 to get to that shape. And you keep going on like this. Keep adding 4. 4 plus 4 is 8. 8. Oh, I'm sorry. You're adding 4. So 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 4 is 19. So once you figure out how each one is obtained from the previous one, and we see that you can obtain it by adding 4 sticks, so you simply had to add 4 to the original number 3 to get the number in each shape in this pattern. Alright, so the first shape has got 3, the second one has got 7, the third one has got 11, and so on. So they want to know what is in the 50th shape. Now you can write down, keep adding 4 until you come to the 50th one, but that will take a very long time. You have to think of some way of easing our calculations. And a nice way is, because we're adding 4, we can look at multiples of 4. Like this thing here, 3 is 4 minus 1. 7 is 8 minus 1. 11 is 12 minus 1. 15 is 16 minus 1. So that's the number of sticks you got in each of those shapes. And now that makes it very easy, because here you got 4 times 1, the second one you got 4 times 2, third one you got 4 times 3, 4 times 4. So by the time you come to the 50th one, you're going to have 4 times 50 minus 1. That's the number of sticks you need to create the 50th shape. And 4 times 50 is 200. If you take away 1 from that, it's 199. So that's the number of sticks that you will need in the 50th shape. Okay, now we go on to problem number 14. Problem number 14 says, what is the largest 2-digit number that is the sum of 2 different perfect squares? What is the largest 2-digit number that is the sum of 2 different perfect squares? So you're going to add perfect squares. Perfect squares are square numbers, like 25. That's a square number. 5 times 5, or 16, it's 4 times 4. All right, so you're going to add 2 perfect squares. So let's write down all the squares that we know: 1, 4, 9, 16, 25, 5 times 5, 6 times 6, 7 times 7, 8 times 8. 9 times 9. Now you have to eliminate this because you are talking about only 2-digit numbers. So I'm going to add 2 numbers from this lot. These are the perfect squares. I'm going to add 2 numbers from this lot, and I want to try to find the largest possible answer that you can get. So evidently you have to start with 81 and add to it the one next to it, but you want your answer to be a 2-digit number. So 81 plus 64 is not a 2-digit number. It's 145, which is a 3-digit number. So this is not a 2-digit number. 81 plus 49 is also doesn't work. 81 plus 36 doesn't work. 81 plus 25 is 106. So the first one is 81 plus 16, which is 97. Right, so you're starting with 97. Okay, so you finished all the sums which have got 81 in it. Now you take all the sums which have got 64 in it. You're adding perfect squares. You can get 64 plus 49, but that's too much. It's not a two-digit number. 64 plus 36 is 100. Well, that just missed the boat. So the next one will be 64 plus 25, which is 89. So like that, now if you start with each one, start with 49, you see 49 gives you 49 plus 36, that's 85. Right? And so on. And then if you look at the sequence of numbers, right, you want to know which is the largest of all of them. The answer is 97. So that's the largest two-digit number that you can create. Okay, so let's get on to the next problem. It's number 15. Number 15 says the sequence of natural numbers is divided into groups of 3. Well, you can see 1, 2, 3, that's a group of 3. The next group of 3 is that. The next group of 3 is that. And the question is, what is the sum of the numbers in the 100th group? Okay, so the 100th group is, let me just get rid of this black color. Oh, it hasn't got rid of it. Sorry, this is taking a much longer time than what I thought it would take. I'm trying to black color. Right, okay, I'm there. So the 100th group will have 3 numbers in it. And we want to know what the numbers are, because you need to add those numbers. So can we see any way of predicting what the numbers are? So if you study this thing carefully, you'll see the last number in the first group is 3, the last number in the second group is 6, the last number in the third group is 9. So you can figure out that the last number in the 100th group is 300. It's 100 times 3. 3 times 1, 3 times 2, 3 times 3. So in the 100th one, you're going to have, so this is 300. But now the rest is easy. You can fill this 299, 298, but they are consecutive numbers. And then you want to add these 3 numbers. And that will be, sorry, it's 897. Woo! What's wrong? My age is catching up with me. 897. Okay. Well, how did I get 897? I can see it's actually 900 less 3. Less 1 here and less 2 there. So I can get the answer straight away. Okay, so that now takes us to problem number 16. Problem number 16 says the following. A tower of 4 squares is shown. Okay, you got a square here, you got a square here, you got a square here, you got a square here. And the area of each square is a quarter of the area of the square just below it. So the area of each square is a quarter of the one which is underneath it. All right. Now we don't know the areas of these squares, But you do know the area of each one is 4 times the area of the previous one. So let's just look at the smallest square, and you will see we don't know what the side of it is, so let's call it x. And because it's a square, that side will also be x. Okay, so we are also told that the height of the tower is 30 meters. So we know how tall it is. So we go up to that. Like that distance is 30. So let's record that in this picture so we know we can use it when the time comes. All right. Now, this side is x. The area is x squared. Area per square is side times side. So that is x squared. Now it says that each one is a quarter of the previous one. So for this to be x squared, this will have to be 4x squared. Then you will get that area is a quarter of this. And this one here will be 16x squared. You have to multiply this by 4. So 64x squared. So each one is a quarter of the next one. Okay, and now once you got that, you see I got the height of the tower. Let's see the height of each one. This height here, the area is 4x squared. I just want to get rid of that line there because that line is right in the way. It's the wrong line anyway. So here you got the area is 4x squared. So what is the side? To get to the area, you have to take side and multiply it by itself. So side multiplied by itself is 16x squared. So the only way you can get that is, oh my goodness. If the area is 16x squared, the side is 4x. 4x times 4x is 16x squared. And likewise, here, the side will have to be 8x. Because 8x times 8x is 16x squared, so the area is equal to 8x. So now we have, this side here was 2x. This area was 4x squared. So now that tells you that you can add up these 4 and the answer will have to be 30. Right? Because this is the full height. So it's x plus 2x, that length plus that length plus that length plus that length gives you the entire height of the square. So that gives you 1 plus 2 is 3, 3 plus 4 is 7, plus 8 is 15. So you get 15x. So 15x is equal to 30. That's the height. But now that gives you an equation. You can solve for x. X is 2. So your original square was 2 by 2. There's 2 length and 2 breadth. But the question is, what is the length of the largest square? So let's go straight to that. The length of the largest square is that one, right? We calculated that, and x is equal to 2, so this is 8x is 16, 8 times 2. and the units are square centimeter. Now wait a minute, this is the length, so it's just centimeters. Sorry, the area would have been square centimeters. So that's the answer to this question. All right, now let's get on to problem number 17. Okay, Hamdani is out running. He is now 3/5 of the way through the second half of his run. Now we have to interpret that. He's 3/5 of the way through the second half of his run. Okay, now just imagine that he's running in a straight line, right? And suppose he started at the extreme side here. This is your starting point, and this is your end point. Start and end. Now, he's 3/5 of the second half of his run. So, the second half will be this one. And he's finished 3/5 of this. So he's here somewhere. But it's 3/5 of half, right? Because this thing here is half. So this is 3/5 of half. And the question is, what fraction of the whole run as he ran? It will have to be from here up to here. That will be the fraction. So how do you get that number? Well, firstly, it's equal to a half. That takes care of the first part. And then you have to add that bit to get to that, which is 3/5 of half. Right, and now you have to calculate this. Right? Leave the first half intact for the moment. 3/5 of half is 3/5 times half. So the numerators, if you multiply it, 3 times 1, and the denominator is 5 times 2, which is 10. So 3/5 of half, of means times, is 3 times 1, which is 3, 5 times 2, which is 10. So this is what we have to add, a half plus 3/10. We need to know what fraction of the whole, as it completed, is half plus 3/10, and half is 5/10. Half is 5/10. 5/10 plus 3/10 is 8/10. So the answer is 8/10, which is the same as 8:10. So what fraction of the whole has it completed? 8:10. This is the same as 4:5. Because 8/10, both are even, so you can cancel the 2's. So observe, 4:5 is the same as 4/5. 8:10 is 8/10. See? So the answer to the question is 4/5. All right, let's get on to problem number 18. Let's get 18 up here. Oh, come on. Okay, we're looking at now problem number 19. 17 is finished. 18, yeah, we're looking at number 18. 18 says, in a 5-digit numerical code, each group of 4 adjacent digits adds to 19. So we have to make sense of what it's saying here. Now, you take a 5-digit number. An example of a 5-digit number is like 35718. So that's a 5-digit, it's a numerical code. Each group of 4 adjacent digits. It means if I take 4 digits which are next to each other, I'm going to get 19. Here, if I add them, I get 8, 16. So this doesn't work, right? Okay, so if you take any group, now this is all, there's a second group of 4-digit numbers, those two, right? And the 3-digit numbers also are here. These are the adjacent 3-digit numbers, and so on. So it's given here that this 5-digit code has got some properties. Let's draw the 5-digit code. What I want to do is I want to put it in the form of a box, which is usually a very nice way of writing a number with several digits. Just put a box so you can keep track of what is the first digit, what is the second digit, and so on. And so it's a 5-digit number. Let's divide it up in 5 parts. Okay, so they don't look equal, but never mind. We want to use the information now. They say each group of 4 adjacent digits. Let's take this first group of 4 adjacent digits. They add up to 19. When you add the 4 numbers, oh, I'm sorry, there's supposed to be 4. We're all the way up to there. Those 4 numbers add up to 19. Right? 4 adjacent digits add to 19. And each group of 3 adjacent digits adds to 15. Now, there's lots of adjacent 3-digit numbers, but I'd like to have a look at this one here with good reason, because this 4 adds to 19 and these 4 add to 15. These 3 add to 15. So the 4th one must be 4. 15 plus 4 is 19. All right. Now, for the same reason, if you add up these 4 numbers, you're going to get 19. And if you add up these 3 numbers here, let's take these 3 numbers. If you add those 3 numbers, you're going to get 15. So, if you go from this end, you're going to get 19 this way and 15 this way. So the first one is also a 4. So now I suggest to you that we can fill up all the squares, because any 3 digits add up to 15. So you got 4 plus 4 is 8. This has to be 7. And again, you got 4, 7. You have to have another 4 here. And here you got 7, 4. So you have to add another 4 here. So they all will add up to 15. And the question says, what is the sum of all 5 digits? Very important to answer the question. All 5 digits. So you got all the 5 digits. There are 4 4s and 1 7. So if you add up all that, you get 23. 4 4s plus 1 7. 16 plus 7. Okay, so that takes care of problem number 18. So let's move on to problem number 19. We're nearly there. Problem number 19, again, it's a 4-digit number. So as I said, I'd like to draw a four-digit number in the form of a grid like this. Okay, and then it's a four-digit number, so I'm going to break it up into 4 parts. All right, what does it say here now? It said the sum of its digits is CC. So this is of the form ABBA. ABBA, EBA. It's a famous band. Okay, now A and B represent different digits. By digits you mean 1, 2, 3, 4 up to 9, or even 0. Okay, now they say the sum of its digits is a 2-digit number, CC. Okay, let's add these 2 digits. These 4 numbers. You get A plus B plus B plus A. The sum of its digits is a 2-digit number, CC. Let's put it down like this. So what do you have? You have 2A plus 2B equals, now be careful, don't say this is 2C. Right? This is not 2C. This is a 2-digit number. But both the digits are the same. Okay, so the various possibilities for this, you can have 0, 0, 1, 1, 1, 2, 2, 3, 3. Both the digits are the same because they got the same representation. But it is said that the sum of its digits, 2A plus 2B, it can't be very big because the largest value A has is 9. This is the same with B. So the largest value that this has is 18, and the largest value that this has is 18. So the largest possible sum is 18 plus 18, which is 36. So we have to rule this possibility out because the sum of those 4 digits cannot be as large as 44. Okay, now you know it's going to be either that or that or that. But watch, 2A plus 2B is even. An even number is 2 times something. So when you add these 2 even numbers, from your own experience, you know that the sum must be even. So that eliminates these, because these are not even. Those are not even. So now we have that the sum that we are looking for, this number here, is 22. So when you add the 4 digits up, we just saw now that the answer is 22. So that means that A plus B, 2A plus 2B is 22. A plus B must be 11. Because 2A plus 2B is equal to 22. All right, they wanted A plus B plus C. And what is C then? Oh, we already said that this is 22. So C is 2. So A plus B is 11. And C is already 2. So the sum of all the 3 numbers is 11 plus 2, which is 13. Okay, and then finally, let's go to problem number 20. So problem number 20 is this. Let's read it. In the number pattern 2018, 1 to 1, 16. It's a funny looking pattern. 2018 and it comes to 1 to 1. What's the rule there? It's 16. Each term is the square of the sum of the digits of the previous term. Oh, all right. So you got 218. The sum of the digits is 2 plus 1 plus 8. It's 11. It's the sum of the digits, and it's equal to the square of the sum of the digits. So 11 is squared. 11 times 11 is 121. Okay, that's exactly as we see here. All right. Here now again, you take this next one, you add the digits. It's 4. 4 squared is 16. 4 times 4. So you got it. Here is 1 plus 6 is 7. Let's go on. And you square that, you get 49. 4 plus 9 is 13. Square it. 13 squared is 169. It's a nice fact to remember. It's nice to know some of these squares. For Pythagoras' theorem, it's always useful. 13 squared is 169. 14 squared is 196. So it's nice to know a few squares. Okay. Right, now it goes on like this. 169. 1 plus 6 is 7. 7 and 9 is 16. So 16 squared is 256. Now you got 2 plus 5 is 7. 7 plus 6 is 13. 169. And now you get 16 squared is 256. So you see that this sequence actually starts repeating. (169, 256, 169, 256). They stop at some point and they start oscillating up and down. 169. All right, now you need to know the 100th term in this pattern. Okay, it shouldn't be too difficult. It's going to be either 169 or 256, but which one? Okay, so you want the 100th term. The 100 terms altogether. Now let's just take out these bad guys here. That one, that one, that one, that one. And we take them out. And then from beyond now, you only have 169 and 256. All right, now you'll notice that if this is the first one, if you look at just this part here, right? The first term is 169, second one is 256, third one is 169, fourth one is 256. So we need to know what term are we looking for here. 4 terms have been taken out, right? So the remaining sequence has got 96 terms. These 4 terms are removed. Now amongst these 96 terms, I want to find the last term, which is the 96th term. But you'll see here that the odd terms are 169. First term is 169, second term is 256, and so on. So the even terms are 256. This is an even number. and the even terms are 256. So your 100th term, that's a 96th term there, so it has to be the 100th term from this part, is 256. That is the answer to the 20th and the last problem. Okay, everybody, I hope you, if you have written the Olympiad on the 11th of March, you can go and check to see what your answers are, and it will be very nice if you get 50% or more in that. Then you will be allowed to move into the second round. Okay, thank you very much for listening, and enjoy the rest of the day.